Alright guys, so I'm going to try something new today. So what I'm going to do is I'm going to record the notes for today and then upload them to YouTube so that you guys can watch them, pause them, um, and use them at your leisure. So feel free to, as I'm recording this, to pause and play and go back or whatever you need to so that you're getting everything that you need to out of this PowerPoint. And in addition, make sure that when I'm going through this, you guys have the note-taking guide open and are filling that out as I'm going through this, okay? All right, anyways, so ecosystems are dynamic interactions between plants, animals, and microorganisms and their environment working together as a functional unit. Ecosystems will fail if they don't remain in balance. No community can carry more organisms than its food, water, and shelter can accommodate. Food and territory are often balanced by natural phenomena such as fire, disease, and the number of predators. Each organism has its own niche or role to play in an ecosystem. So I picked this slide because it shows ecosystems of the world. So cool things to point out about this slide are that the marine covers 71% of the world's surface. Freshwater only covers 0.8% of aquatic ecosystems, so that's a pretty small chunk. And then other things. So what's interesting is that of the land, 33% is covered by desert, 30% is covered by forests, 31% are covered by of the landmass of the earth, that is, are covered by grasslands, and then 6%, which I think that number should actually be a little lower, more like 2 to 4% are covered by rainforest. So what's interesting about the rainforest, though, is that rainforests are responsible for more than 50% of the species on the planet. Okay, so next we're going to get into what shapes an ecosystem. So, if you ask an ecologist where a particular organism lives, that person might say the organism lives in a Caribbean coral reef, or in an Amazon rainforest, or in a desert in the American Southwest. Those answers provide a kind of ecological address, not unlike a street address in a city or town. An ecological address, however, tells you more than just where an organism lives. It tells you about the climate the organism experiences and what neighbors it is likely to have. That address tells you what ecosystem an organism lives in. But what shapes the ecosystem in which an organism lives? So what shapes an ecosystem are biotic factors, so biological factors, and abiotic factors, so physical factors. So here you can see, here's a picture of Pride Rock in The Lion King, and you can see there are both abiotic and biotic factors in this picture here. So you can see that there are the different living organisms, so Simba and the different other Rafiki and the other animals in the picture are the biotic factors, and then Pride Rock, the air, the clouds, those are the different abiotic factors. Okay, so here's another summary of that. So we can see here from this figure that the biotic factors and the abiotic factors go together to make up the ecosystem. So now let's talk about each of these individually. Okay, so biotic factors are biological influences on organisms within an ecosystem. Biotic factors include the entire living cast of characters with which an organism might interact. So these include things like birds, trees, mushrooms, bacteria, all of the living organisms. So in the food web that I put on the screen, you can see this includes kookaburra a wedge-tailed eagle, a rabbit, a snake, grass, a grasshopper, and a mouse. So let's take a bullfrog, for example. Biotic factors that might influence a bullfrog and its environment might include the tiny plants and algae that it eats as a tadpole, the herons that eat the adult frog, and other species that compete with the bullfrog for food or space. Okay, in addition to this, the ecological community also are part of that biotic factors. So we talked about this yesterday. So the community interactions also are a part of the biotic environment. So I believe on your note-taking guide it asks you to list the 5 different interactions that we talked about yesterday. So think about that. If you need to, you can go back to the slides from yesterday and list those 5 community interactions. So now, since we really talked about biotic factors yesterday and those ecosystem interactions, today I want to focus more on the abiotic factors. So the abiotic factors, those are the physical or non-living components that shape an ecosystem. So you can see here, I included a picture. And so you can see some of the abiotic factors include the sunlight, wind, rain, water, and soil. Okay, so other things that are also included in these abiotic factors are climate, so the temperature, precipitation, the humidity, wind, nutrient availability, soil type, and sunlight. So for example, going back to our bullfrog example that I'm going to try to use as a recurring theme throughout this, the bullfrog is affected by abiotic factors such as the availability of water and the temperature of the air. Okay, so let's talk about climate and weather a little bit. So you know that species vary in their tolerances for conditions outside of their normal ranges. So if you live in Michigan, for example, you know that you can't grow banana trees in your backyard. Bananas are tropical plants that need plenty of water and heat. They won't survive in the freezing temperatures. And also, it might not be obvious that cranberries won't grow in the Rio Grande Valley of Texas. Cranberries need plenty of water and a cold rest period. Therefore, they can't tolerate the months of very hot weather that occur in the Rio Grande Valley. Bananas and cranberries, like other plants and animals, vary in their adaptations to temperature, rainfall, and other environmental conditions. So what I mean by that is that different organisms live in different conditions. So just like your common houseplants or rainforest plants wouldn't be able to survive in the desert, but cactuses can because of those different conditions. So this is why climate is important in shaping ecosystems and why understanding climate is important in ecology. So a lot of this should be reviewed for you guys that took Physical Earth or Accelerated Physical Earth or whatever, but we're going to go through it just briefly. So weather. Weather is the day-to-day conditions that Earth's atmosphere or on Earth's atmosphere at a particular time and place. The weather where you live might be clear and sunny one day and cloudy and cold the next. This is especially true considering that we live in Colorado. And then next is climate. So climate, on the other hand, refers to the average year-to-year conditions of temperature and precipitation in a particular region. So the way that I like to think about it is that climate is what you'd expect for an area. So you might expect it if you're in, Pueblo in the summer to get 90, 100 degree days. That would be the climate. That's what you're expecting. But weather, on the other hand, is what you get. So there are those days that are 60, 70 degrees in the summer. So weather's what you get. Climate's what you expect. So moving on, we're going to talk more about climate. So climate is caused by the interplay of many factors, including sunlight, trapping of heat by the atmosphere, which is important, and we're definitely going to talk about this one here in a minute, latitude, and transport of heat by winds and ocean currents. And then amount of precipitation, and the shape and elevation of land masses. So the energy of incoming sunlight drives Earth's weather and helps determine climate. As you might expect, solar energy has an important effect on the temperature of the atmosphere. At the same time, the presence of certain gases in the atmosphere also has an effect on its temperature. So then what I included for you guys here is the different climates of the world. So you can see there are tropical, dry, moderate, continental, and polar climates, and subcategories in each of these. So next up, we're going to talk about the greenhouse effect. So temperatures on Earth have to remain within a suitable range for life. And the reason this happens is because the biosphere has a natural insulating blanket. So the atmosphere is our natural insulating blanket. So a key concept, carbon dioxide, methane, water vapor, and a few other atmospheric gases, these are our greenhouse gases, trap heat, energy, and maintain Earth's temperature range. So these gases function like the glass windows of a greenhouse. So I included a diagram for you guys here, so you can see that three things happen when the sun's rays hit the Earth. There, I hid the my little webcam in the corner there, so you guys can see the picture a little better. But so one, some radiation that comes from the sun is absorbed. So the Earth absorbs radiation from the sun. Some is reflected. Greenhouse gases absorb some outgoing radiation, and then the third thing is greenhouse gases emit absorbed radiation. This warms the Earth and its atmosphere. So, just to define the greenhouse effect for you guys, it's the natural situation in which heat is retained by this layer of greenhouse gases. So, greenhouse gases allow solar energy to penetrate the atmosphere in the form of sunlight. Much of the sunlight that hits the surface of our planet is converted into heat energy and then radiated back into the atmosphere. However, those same gases do not allow heat energy to pass out of the atmosphere as readily as light energy enters it. Instead, the gases trap heat inside the Earth's atmosphere. If these gases weren't present in the atmosphere, so that if they were not there, Earth would be 30 degrees Celsius cooler than what it is today. And I think at this point, guys, I'm going to break this into two videos. So this is the end of part 1. Look for part 2 as well.